Hello everyone and welcome to the playlist on geometric constructions. So in this video series I'll be telling you how to construct various geometric constructions. So in this video I'll tell you how to bisect a given line segment. Let's get started. So first let me construct a line segment. Okay, you take your scale, just draw line of any length. Okay, so this is your line segment and these are your two endpoints. Okay, let's call them A and B. Let me call this A, let me call this B. Now you open your compass and stick this needle, stick the tip of your compass at your one end, okay, at B. And now what you do is you approximate your half. So this is where approximately, this is the half approximately. So you open your compass greater than the approximate half. So this is sufficient enough. And mark and draw arcs. Okay, draw these arcs. And then you shift to point A. Do not change the length of this compass, okay, and make these two arcs such that they intersect. So now you get these 2 points, okay, this one and this one. Now you join these two. So where this line intersects your AB, this point, let's call this C, divides AB into two parts, and this line is the perpendicular bisector of AB. That is, this angle is 90 degrees. Okay, now let's measure this quickly just to see if it works. So this is roughly 12 centimeters. Okay, AB is 12 centimeters and your CB is 6 centimeters. So AB is also 6 centimeters, as you can see. Now let us see why does this work. So in order to prove this, let's just construct it again. Okay, so we have a line segment, and what did we do? We opened our compass to a distance which was greater than the approximate half. So this is somewhere your midpoint will lie, and you open your compass. So you made this arc from this point. Okay, we just label them A, B. Okay, and then you didn't change your compass length and made this arc. Then you did the same procedure from A without changing your compass length. So this arc and this arc, and finally you join these 2 points. Okay, you get this point, you get this one and you join these two. So this point was your midpoint. Okay, now if I connect A to this one, let's call it P. Okay, and also draw PB and do the similar drawing below the line. So let me call this point Q and join BQ and AQ. Let me call this point as C. C is the midpoint of AB. We need to show that C is the midpoint of AB. Now can you notice that all the red lines are equal in length, will be equal in length? They have to be. So this length equal to this one, equal to this one, equal to this one. Why? Once you realize this, many constructions will become very easy for you to understand. So it all lies in the fact that we didn't change our compass length. So this is your point. And if you draw an arc without changing your compass length, okay, then you will get a circle. Okay, just try this again. This point, much better. Now in a circle, any two radii, okay, this one or this one, they are the same, right? Now when you open your compass and you draw an arc, you don't draw the entire circle, okay, you draw only a part of it, but still these two radii have to be equal, because if you were to extend this arc, okay, something like this, then you would have gotten a circle, and these two lengths would be the radii of this big circle centered at V. So these two lengths are equal. Okay, and similarly you can do this to A, but since you didn't change your length of your compass, this length and this length is the same. So AP is same as PB, and AQ is same as BQ, and these two are equal because of this reason. And now we can apply congruency. So in triangles, these two triangles, okay, in triangle APQ and this one BPQ. So AP is the same as PB, okay, AP is PB, AQ is the same as QB, AQ equal to QB, and this PQ is common to both of them. Alright, so PQ equal to QP, now P, because it is common to both of these triangles. From this you can say that triangle APQ, okay, is congruent to triangle BPQ. And once you get this relation, everything falls into place. How? If these two triangles are equal, then this angle will be equal to this angle, right? Because corresponding parts are equal. So if this is theta, this will also be theta. And now you can shift your focus to these two triangles, okay, APC and BPC, okay. So triangle APC and triangle BPC, because you want to prove that AC is the same as CB. So in these two triangles, AP is equal to PB, we know, because they are radii of the same circle, okay, and PC is the same as CP, because you know this segment PC is common to both of these triangles, and this angle, okay, APC is equal to BPC, both of them are equal to theta, okay. So APC is equal to BPC, okay, equal to theta, and we have already proved this because these two triangles are equal, are congruent. So corresponding angles have to be congruent, have to be the same. Now in these two triangles, this side is equal, this side is equal, and this side is common, and your included angle, so angle between these two sides, is also the same. These triangles are also congruent through the SAS criteria. So triangle APC is congruent to triangle BPC, okay. No? SAS criteria. Side, angle, side. So angle should be between two sides. This angle is between these two sides. This angle is between these two sides. And the sides are equal. So this means APC is congruent to BPC, which means AC is the same as CB. Okay, so these two are equal, which means C has divided AB into two equal parts, or in other words, C is the midpoint of B. So you do this procedure and you find that AC is equal to BC, and this angle will be 90 degrees. Well, why? Well, if you see again in these two triangles APC and BPC, these two angles have to be equal. Let me call this X. Okay, so the corresponding parts are equal. If this is X, this is also X, and these two angles lie on a straight line, so their sum must be 180 degrees. So X plus X is 180 degree, okay, which gives X as 90 degrees. So PQ not only bisects AB, but PQ is also perpendicular to AB. So in this video you learned how to construct a perpendicular bisector of a line segment and why it works. See you later. Thanks for watching.